In this investigation, we're going to develop a new tool for reasoning about exponential relationships. So let's start by considering the equation 2 to the x equals 32. Let's think about how we could solve this equation just by thinking about exponents. So if we start with the value of 2, then we just have a value of 2. And then if we multiply by 2 again, we get a value of 4. If we multiply by 2 again, we get a value of 8, and then a value of 16, and then a value of 32, just by doubling each time. So if we do 2 times itself 5 times, we get a value of 32, which tells us that 2 to a power of 5 equals 32. And therefore, this 5 is the solution to our original equation. 5 is the exponent on a base of 2 needed to produce a result of 32. Now, this equation was relatively straightforward to solve just by thinking about exponents, but things can get a little trickier. Like, consider the following equation: 2 to the x equals 34. We know that 2 to the 5th is equal to 32, so 2 to the 6th is equal to 64. And so if we want a result between 32 and 64, like 34 is, the exponent has to be between 5 and 6. But we don't know exactly where between 5 and 6 this exponent must be. Now we could solve this equation graphically by graphing y equals 2 to the x and graphing y equals 34 and finding an intersection point and so on. But that only gives us an approximation. So in this investigation, we're going to introduce a new tool called Logarithms to help us determine exact answers to equations like this. So finding the exact exponent on a certain base needed to produce a certain result.